Hi folks, George here. Well, it's been a while since I made this kind of long prepared videos and I'm really excited to see you and well, to talk a little bit about what I'm going to show you today. So, as lots of you may know, I am a big Frusciante fan. I mean, all my content is really based on him. And well, I have been chasing his tone for several years, since I started my guitar journey 5 years ago. I have always been puzzled by Stay Mercadium. I mean, the album, the John's outfits, John's tone, John's expressions, his solos. I mean, everything about that era really inspires me a lot. And I can easily say that that's my favorite era of the whole Chili Peppers catalog. But there was something that puzzled me a lot about his tone. And it was the kind of overdriven first tone that wasn't like a big mouth, it wasn't the DS2. And it really puzzled me a lot. Until February 2021 when JFFX launched the Fuzzrite. So to them, I mean, they did an awesome campaign showcasing where John used the Fuzzrite, I mean, all this kinds of video, Victor Fideli's work, and I was really thrilled about it. But I was a broke university student, and I never managed to score $150 to buy a Fuzzrite, less JF Fuzz or Right from Lemon and Ginger effects, because well, the postage itself coming from there to Peru, it will be a lot. So I had some free time, and then I decided to start knowing how to build pedals. And after some time, I came up with this. So this is my Germanium Fuzzrite clone. I mean, I love everything about this, since the transistors I used, to the work I made, to the aesthetics. I mean, it looks awesome. The only thing is that running on batteries, because well, I wasn't able to get chips to do my voltage inverter, but besides that, it works as a charm. But I wanted also to sometime being able to show people how to build this circuit. I mean, I hugely respect Will Galuccio's, the guy at Lemon and Ginger, and the guys at the FFX work. And I think that, well, doing everything from the research to the campaign to the building of pedals and everything, I mean, it's hard work and it has to be remunerated. But for someone that isn't able to afford it and that has maybe a little free time, a soldering iron and some let's say patience, well, I wanted to teach those kind of people that you can build one. I mean, you can build a Fuzzrite without too much. I mean, it isn't hard to build one, but I wanted to showcase this for anyone that, I mean, has a soldering iron again and some patience and would like to take on this project. So I mean, this is a really long video, I apologize for that, but I really wanted to show every step of it, so even beginners can get his soldering iron again, try to build this. It's awesome. I try to include some samples, and I apologize if this isn't the greatest quality, but my Behringer interface isn't on its prime, on its peak level, but well, I hope you really like it, and this is it. Okay, so now to the actual tutorial. So first of all, sorry for this being so messy. I'm printing the schematic because I want to explain to you a couple things. I'm just going to write it down here. But I highly suggest you to do this because, well, you need to have a visual of what you're building. So, well, you need a guitar pedal enclosure. So, you know, I have this pre-drilled from a friend. Well, I forgot him to tell him to do the holes up here just to cosmetically reference the OG Fuzzrite. Of course, you need a couple jacks, input and output. These are standard 1/4" jacks. Well, we're going to need, you know, your basic soldering tools, so a soldering iron, some solder, flux, and I highly suggest you having this plunger to remove solder, because, you know, if you mess up, it's nice to have a handy tool to just remove that solder and start again. Now, for the actual circuit, well, I forgot to tell you a couple knobs because of cosmetic reasons. So for the actual circuit, first of all, a 3 PDT switch. Why? Because we're going to use it to connect, I mean, the effect and to power the LED. as I told you before, well, in this case it's optional. If you just don't want to use an LED, you can just use these 6 lugs of that rapidity. I'm going to explain it later. And well, if you want an LED, just an LED. Some strip wires, because well, these are handy. PCB. Let me make you a small disclaimer. If you see that these parts, I mean, you can clearly see that these have already been used. Just because I built the circuit like point to point, something quick, just to check if everything works okay, and then I start building it on the PCB. So the heart of this circuit, as you can see up here, are Q1 and Q2, that are 2 germanium transistors. The material is important. I mean, if you want to use silicon transistors, I mean, just not going to sound right in the circuit. Just try to use germanium transistors. So as you may see here, the values are like 2N2613 and 2N408, but just look for a couple germanium transistors. Here I'm using a couple AC188 transistors. These are really easy to come across. I prefer to use Japanese germanium transistors that I normally scavenge from old radios that are quite common where I live. Let me see, for example, this one. But you can use any kind of germanium transistor you want. This circuit isn't as big as a fast phase, for example, when you like a specific type of transistors. Now, here you can see that you need a couple pots. You need a volume pot that is 500K and a tone pot that is 350K. But this one is really hard to come across, so we're going to use a 500 kV for tone. Well, it's actually that, but we're going to use that one. So here I have 2 of them. Don't let it fool you, this is a double pot, it's a double 500K pot, so I'm just going to use one side. And you need some capacitors. In this case, first of all, you need 3 473 capacitors, so give me a second. The material doesn't matter, and I'm using actually 3 different material capacitors, so these are 473. A couple 222 code capacitors. And some resistors. In this case, you'll need this one that is quite rare to come across. It's a 10 mega ohms, a 1 mega ohm resistor, a 100K one, a resistor from any value from 2K to 10K just to protect the LED, a couple 22K resistors, and a 47K resistor. We also need a electrolytic capacitor that, well, in the schematic we're using 25U, but I'm using 10UF because, well, it's just for filtering. Okay, so we're actually going to start to build. So first of all, I highly suggest you to have some strip wires, because we're going to need to connect stuff that isn't like physically close, but you need to connect it. So well, it's useful to have these ones. Now, I'm going to, first of all, dissect the circuit. So first of all, you go to the input. So this will be your guitar input into Q1. So this is like the first part of the circuit. What happens is that the signal comes into one fuzz stage. It runs the signal here in the germanium transistor. It creates fuzz, inverts the phase, and then it feeds it to the second transistor that actually inverts again the signal and well, cascades this into this, creating even more fuzz. Sorry, it like blends between those 2 stages. I mean, this is fuzzy and this is fuzzier, and you blend between those and you have the Fuzzrite sounds. It isn't like, for example, a standard fuzz phase when you have an input transistor that feeds into another one, overloading it and creating more fuzz. No, this one is like 2 separate fuzz circuits, let's say like that, being blended between each other, but they're really similar. I mean, both transistors are surrounded by a capacitor that is 473. Their 2 middle lugs are connected by a resistor. Then they have a resistor going to the power supply, and another capacitor just for tone. So, I mean, the actual build is really similar in both transistors. Well, each transistor has 3 lugs, so you need to note that the emitter goes to bridge. How do you know what's the emitter? It depends. You have to check the schematic. For example, in these transistors, there is this like little pointy thing that shows you where the emitter is. So this will be the orientation for the transistor. But for example, in other ones like this Japanese transistor I have, they're actually colored. So I know that the blue one is the emitter. But you need to check, I mean, your transistors, how can I say it? Information. I forgot the word for it. So first of all, we're going to connect the first 473 capacitor to the 10 meg resistor, and then to the middle lug of the Q1. So this, I'm going to use this for Q1. So we're going to connect here the capacitor and the resistor. So okay, so now that I have got these 3 together, you can see them. I mean, we're going to solder. So we're going to connect, first of all, the 3 middle lugs. So Q1 to the 473 capacitor to the middle of the 10, to one lug of the 10 meg resistor. What I actually do is like I use something to just put some flux in the parts I'm going to solder, and then I'm actually going to solder. Just try not to use like too much solder, because you may have accidental breaks. So now I have to connect them. How do you connect these holes? Just put a little bit more of solder, so it flows and it makes like a bridge between all parts. Yes, as I told you before, try not to use too much. Okay, so finally we've made the first link. So as you can see, this is connecting these 3 parts. Now, as I said before, there is a side that is very populated, and it's the collector of both transistors. So we're going to connect here a 473 capacitor. I'm going to use this one. Well, let me see. Yeah, this one. Then we're going to connect a 22K resistor. It's going to be this one, the smallest one, and a 222 capacitor. So I mean, these are connected straight to this side of Q1, to the collector. So let's populate this part of the board now. So I want to apologize for the last cut. My phone actually turned off. But okay, as I was telling you, what we need to do now is we have to connect the second transistor stage. So what we're going to do to make this is that, first of all, we put the second 473 capacitor from, you know, the bunch of components surrounding the collector of Q1 up to the base of Q2. But remember that, as I told you before, we have to, as we did before with Q1, we have to connect a resistor with the 2 middle lugs, to the base, from the base to the collector of the second transistor, as we did on the first one. So I'm going to grab the 1 meg ohm. Well, you have to make sure that we're going to put it before the second transistor. So, well, as I did before, this pointy arrow tells us where the emitter is, to identify it as ground. Okay, we're done. So, oh god, I did it backwards. Okay, it fit in finally. So, we're going to put a couple, you know, a couple soldering points just to hold everything in place. Specifically, the 3 parts we want to, oh, let me see. The 3 points we want to connect. So this is, as you can see, okay, so we want to connect these 3 points. So let's time to solder. So as you can see, it's quite time consuming, you know, it's not, I mean, you don't take so much time like soldering, but actually placing the components in the right way. So I mean, I think that's the hardest part. If you master how to solder, I mean, you're not going to have so much trouble with that, but the component placing is quite difficult. Okay, so we connected all 3 points. Okay, I think that we're going to have to, I'm going to have to make another video because I'm like, my camera, I don't know why it's not focusing. Okay, so these are connected now. Now we want to make this middle 1 meg ohm be connected to the collector of Q2. So we'll just like bend it over just to put it next to it. So okay, we're leaving some holes because we have to populate this part of the board. So now we have to put a 47K resistor, that is this one. Ouch. A 47K resistor and the second 222 capacitor in place. As before, facing up, facing the other side to be careful not to connect it. Well, that's it. Let's solder again. Yep, everything's in place. So we have got the 4th bridge here. Now what we want to do is that we need to link, I mean, 47K with a 473 capacitor that we have here, and then connect it to a 100K resistor. So we're going to put it right here, then put the 47K sorry, the 473 capacitor, and then the 100K resistor. Just be careful because the 100K resistor is connected to the 22K resistor, so we need to make everything. Okay, sorry for that, the cut actually broke the resistor. Yeah, this is like a possibility in every build, so let's put it another one. So this is how it should look like. So connect the 47K with the 473 capacitor, with the 100K resistor, and that with the 22K resistor. So let's just solder everything. Okay, so we've got this soldered. Now as you can see, we've got the 5th and the 6th point connected. I think I'm going to flow a little bit more of solder here. Okay, that's better. So now that this is connected, so let me show you something. So we can see that this symbol means ground. So there are 1, 2, 3, 4, 5, and 6 ground points, excluding obviously the input and output jacks that also need to be grounded. So that makes a total of like 7 points. So sorry, 2, 3, 4, 5, 6, 7 points, of course. What we're going to do, So first of all, as I told you before, I was leaving like this row just to be the ground row. So everything that needs to be grounded just will go up there. So I told you that we were going to need some wire just for that. So actually we need an 8th wire, an 8th point of ground if we're going to use an LED. So this LED, one lock goes to a resistor. I'm going to show you that later. And that goes to 9 volt, and the other side goes to ground. Okay, so we need 1, 2, 3, 4, 5, 6, 7, and the 8th point of ground. So we're going to just populate this row. Okay, so we need a wire to go to, I'm just using black wires, plain black wires for this one. So we need a black wire to go to the volume out. So I'm just going to try to use a long one. This one sits perfect. Okay, so we've got it. I'm just going to straight up solder it, just for fun, just for making things like tidy. This is hard when you want to wire, but you forgot to use solder to solder a wire. Okay, that's nice. We need another one to connect the 0.05 capacitor we left like literally flying. So we're going to like put it in place in a hole. Okay, so just facing upwards, and we have to connect it to the ground. So I'm going to use this wire because I mean it's actually hard, so I can like mold it to go wherever I want. So now I'm soldering, you know, the point to ground. I mean, I could easily like do a big, you know, use a bigger part to, well, you know, make it go straight from one point to another. But I find it better this way just because sometimes the metal from the lugs of whatever part I'm using like tend to touch other things that may cause shorts. Okay, so we need also another like a ground wire. Well, in this case we have covered Q1 and Q2, as you have may seen. Q1 and Q2 are on this line. We needed to, I mean, ground this 473 capacitor. We also have the volume out. We need another one. Well, actually we need this capacitor, so we're going to do the opposite. Why? Because, well, in this case we're going to ground straight up this, and then we're going to use a wire to connect it to the battery. So let's get to that later. So these electrolytic capacitors are polarized. As you can see, the positive part is grounded, so in this case the negative part goes upwards. Oh, I'm having again the same focusing problem. Okay, as I was telling you before, we need to put the positive onto ground. So we're going to ground it. Oh god. And to remove again some soldering. Okay, so now we're going to solder. Now we have to sorry, we've got this one covered. We need another wire for the LED that is actually not going to be straight up connected to the LED, and I'm going to show you that in a second. So this one's for the LED. Okay, so some flux and the solder. It's nice. Now we've got this one covered. We need also to ground the 22K resistor. So what we're going to do is that the resistor comes from the 0.2 capacitor up to ground. So I've got this one. We're going to connect it to ground, and then to the 0.2 the 222 capacitor. So let's put this 22K, and then let's try to bend the capacitor without obviously breaking it. Also, don't just connect them upwards to not risk the capacitor breaking. Sorry. I mean, that's the good part of using like this stuff to solder. That, I mean, you can see if you got any issue. Just try to fix it without risking the components. This involves a lot of thinking, actually. Okay, so connect it, and now let's connect the ground wire. So what I'm doing now is that I'm letting some solder flow to connect, all the grounds, because this is really important. These have to be connected. If not, no sound will come out of the pedal. Then you have some hum. I mean, there are a lot of problems that are actually caused by not having a good ground connection. So it's really important to know this. Okay, so this one's for the pot, this one's, let me cross this. This one for the LED, and we just need one more ground that is from the jacks. So we're going to just put one more wire, and we're finished grounding everything. So I have been forgetting that I don't need to do it. I mean, I told you before, it's quite tricky doing this because I'm just keen on, I'm just used to solder like from a point of view, but then I remember, oh my god, this guy have to see this. Okay, it's nice. Let's leave some of this to flow. Okay, so we are ready. We have the last ground connection. So the circuit is actually ready up to some point. Now we need to connect the pots. So as you may see, there is the 222 capacitor that is connected to the tone pot to one side. Then the other 222 that is connected to the 22K resistor is connected to the same pot, and that one is connected to the volume. So we're going to do that. But I highly suggest first wiring the two pots together. Oh God. And then wiring it to the capacitors. So in this case, these lugs are like 1, 2, 3. I'm going to just... So we've got the depth pot and the volume pot. So in this case, the depth pot is going to be connected 1 to Q1 capacitor, and lug 3 is also being connected to Q2 capacitor, the 222 one. So both 222 capacitors must be connected to the 1 and 3 lugs of this pot. Then you take a wire from the lug number 2 and connect it to the lug number 3 of the other 500K pot. The lug number 1 goes to ground, and lug number 2 goes to out. So that's what we're going to do. So how we're going to start? First of all, I'm going to link both pots. Okay, so now we have linked the capacitors. The pots. We need to link the Q1 capacitor to this side and the Q2 capacitor to this side. Oh, sorry, I actually think that they're backwards, but okay, I have already wired them this way. I forgot, I don't know, I think on the OG Fuzzrite this was volume and this was depth. I have made it the opposite way, but well, you can just flip over this. It was a confusion of mine, but this is already explained and wired, so I'm going to do it that way. Okay, so we take a couple wires to connect the capacitors to the pot. So as you can see, I left this cap flying, so I'll just, I mean, I hope you're seeing the circuit and not my head. I really hope so. Okay. No, this goes there. Now, remember, Q1, I mean, this time must go here because there's going to be 0 on that pot. And Q2 must go here because it's going to be 10. So, be careful of that. So that makes it up. So, we're going to link now the the link of the 222 capacitor from Q2 and 22K resistor up to this other lock of the other pot. Okay. Now we need to, in this case, take two wires. First of all, connect the wire that we previously wired. We were usually connected to ground this volume pot. So we're going to do it now. And we're going to add another wire, in this case for the out. This is going to be the output to the 3PDT. But let's talk about it in a second. Let's first of all wire. What are we gonna do? You can call me the West. Anyone here likes Harrington? Because I do. You can call me the best, like ooh, oh yeah. Call me the West. All right. So actually, oh, I forgot one important thing. Wiring the input wire. So as you remember, we left this lock of the first 473 capacitor like flying, and it's because, well, that is the input of the circuit, as you can see. So we're going to wire a wire. We're going to connect a wire in place with it. Okay, we're done. So now the circuit is finished. Oh no, I forgot the most important part, the power supply. Oh god. Okay, so the power supply, in this case, as I told you before, it's a positive ground. So you will normally wire, the red, well, we're wiring a battery, the positive to the pedal power and the negative to the ground. But as it is a positive ground, it's going to be the opposite. So 9 volt, as you can see here, is negative. So we're going to connect this wire to the junction of 22 and 100K resistors. So I'm going to flip it over. But as you remember, we left actually a capacitor like flying here, the 25U. So we're going to connect first the negative 9 volt wire, sorry, the negative 9 volt adapter wire to the lock we left flying on the capacitor. Oh, I forgot to use solder. Okay, and we're going to put a wire that's going to link this to the other side. To link to the other side. How long will our line separate my son? Well, I've run out of red wire, so I'm going to use a black wire, but just remember, this is not a ground. This is actually the positive power. Just be careful. As you can see, I'm quite close to the transistor, so don't let the soldering iron to touch the transistor because you may heat it up, and well, these transistors don't do well with extreme heat. Okay, so we actually wired the power, and then this red wire will go to ground. So, oh, this is quite messy, excuse me for that. So, I'm not going to put it through hole, I'm just going to solder it in the back to connect it. Guess I'm growing a little bit lazy of this. I mean, this is taking too long. Okay, so now the circuit itself is ready. We need to connect to the off-board components, that is, well, the 3PDT switch and the LED that I can't seem to find. Okay, here's it. So what we're going to do first is connect. Well, I'm going to show you how the 3PDT is going to be connected. So as you can see, the 3PDT, I mean, this is 9 left, but you have to see it this way. So like, not like this, but like this. Okay, so we've got 9 locks. So let's 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I want, I mean, this works in this way. This is a mechanical connector. So when it's on one position, it connects these locks. When it's in the other position, it connects these ones. So I mean, that's why true bypass, like that's why this connector, I mean, it's like if you had just one long wire, because it mechanically connects everything. So give me a second, please. But what we're going to do is, okay, I'm going to write it down again. So we're going to link 7 and 8 because these are going to connect to do the true bypass connection. 4 is going to be the input jack. 5 is going to be the output. 1 is going to be the effect input. And 2 is going to be the effect output. Let's leave 3, 6, and 9 just there because these are going to be used to the LED. But just let's do it for parts. So as I have this already wired, I'm just going to put the 3PDT. Oh, almost. If you don't have, like I don't do anything to, you know, secure the 3PDT, there's just a couple of, just use this and just hold it from one place and apply some force, and there you are. Okay, so as I told you before, 4 and 5 are going to be the input and output. So seeing it from this way, because it's really important, this is the input, this is the output. So this one's going to be here and this one's going to be in the middle. So some flux for them. Okay, now that we're there, let's link now let's make a bridge in this case from one lock to another to link the sleeves of the jacks. So I mean, let me explain you. We've got a tip, in this case is this one, and the sleeve. The tip is like the one that actually transmits the signal, and the sleeve is ground. So as I told you before, we need to be very careful with grounding, so we have to connect first of all these two. Okay, now we have made this link. We'll proceed to wire. I mean, the signal. But before, I want to tell you what we're going to do with 3, 6, and 9. So I told you before, if the 3PDT switch is in one position, it does this, and on the other end it does this. So the idea is to connect one side of the positive side, in this case, of the LED. Okay, sorry, I'm mixing things up. So the idea is that you see here, we've got an LED positive and negative. So the idea is to connect the negative of the LED to log 3, connect another, the ground wire we left for the LED here, and leave this one without anything. So when you click the switch for this position, that is actually connecting, as you can see, nothing. So it's in straight to out, there will be no light. But when you click and you go to upward position, LED is going to be connected to the negative side and it's going to light up. But you need to protect the LED from giving it straight 9 volt because you're going to burn it. So we're going to put a small resistor here. That is this one. I forgot what value was it, but it worked. So, between 2 and 10K. A smaller resistor will allow more light, a bigger resistor will cut more light, so just be aware of it. So we're going to wire an LED. So I'm going to just cut everything to be able to move it freely. Normally I will just put it straight here and try to make a bridge, but I won't risk it. Call me the West, sayonara by my psychic soldier best. Call me the West. Actually, I would like to suggest you something as I'm wiring this LED. If you've got the project on this state, you can actually test it. Just instead of, you can bypass this whole LED and 3PDT stuff and just wire, ground to the jacks, input jack to here, output jack to here, to the output of the pedal, plug in battery, and you can just connect it and see if everything works. So this could be, to make troubleshooting easier than adding this part. But if you just want to finish everything or you just made this test and everything's okay, you can jump up to this part. Okay, so we're going to connect this wire. Oh. I don't really like these small resistor lugs because they're quite hard to connect, especially if I'm doing on the air without a without a card, a PCB. It's quite a hard task. Okay, that's it. So, well, in this case, just to secure the LED to the box, I'm going to use some rubber that I have here. I'm just going to wrap it around so the LED can protrude on the other side because it's, I mean, I need a stopper here, but I don't have one, so, you know, we have to work with whatever we have. Okay, I think I'm going to work it out later. But, well, now what we have to do is we have to connect these two spare wires we have. Sorry, first of all, we're going to connect the input and output, just to leave the 3PDT ready. So this is the input because it's connected to the 473 capacitor. And this is the output because it's connected to the middle potentiometer, to the pot. Okay, now we need to actually finish the circuit. We need to connect one ground wire to number 6, lock on the 3PDT pot, sorry, the 3PDT switch. I think to mix terms up, I'm sorry for that. And the last thing before we can tell this is completed is to wire the ground to the jack's ground. So friends, finally we fit. Well, there's one point before we can say that we have finished. We need to power the LED. So we're going to run a last wire from the battery to the LED. So I'm not going to risk it too much. I'm just going to go straight here to, oh no, I need a longer wire. Okay, I think this is gonna make it. So I'm going to cut this thing up, repair. I think things will be a little bit easier if I cut this wire and make it shorter, but I'm quite curious to just power this up. You may need to troubleshoot a couple stuff, especially, you know, if you are on your first times, like making circuits, because, you know, sometimes we make accidental breaches, we forget to plug things up, but let's. Okay, it powers up, it lights up. So, well, the idea is to cut it with a hacksaw so you can like make this as small as possible. In this case, I'm not being, as it's a pre-drilled enclosure, I would normally put the 3PDT higher. So I could just this compartment for the battery, but as I can't, I'm just going to put this through here and let it stick out. I mean, I'm not bothered by that. So now we have to put the pots. In this case, as I remember, I think it's depth here and volume here. So let's just, you know, place everything in place. I'm too lazy to use a hacksaw, so I'm just going to cut it. Okay, so now we need to put the spots to mount this. I think the actual word is to mount the spots. Okay, so we have the pots, we have everything in place. So I'm just going to see what I do with the LED. And well, I replug the battery and just close everything up. Okay, so I'm just putting the LED like there. I think I'm going to need a stopper for it to buy one. But our Fuzzrite is alive. So before going to the demo, there are a couple mods I would like to talk to you about. First of all, not everyone uses this 22. Okay, I think this is too. There is a 22K resistor here. Not everyone uses them, so if you want, you can just omit it. I mean, it just makes the fuzz louder in this case if you need to use it in front of a clean amp. It also removes some high frequencies, so it makes like bass, a little bit bassier and way louder, a little bit gainier also. You can increase gain with that. Also, these two 0.002, I mean C3 and C5, they can be changed. These are capacitors, so if normally with a cap you increase the value, you increase the bass. So for example, if 222 seems too trebly for you, you can use a 682, I think there are, or even a 223. In both sides, I mean, this one will change the character of Q1 and this one of Q2. Remember, Q1 is depth at 0 and Q2 is depth at 10. So you're blending these two caps. So I mean, you can, for example, put a 682 capacitor here. So you make this really bassier and this really treble with the 222. So I mean, you can play with that if you think your Fuzzrite isn't sounding right. So the most important part, let's go for a demo.